Well, I'll throw this particular ball horizontally. Then it is going to describe a and it will come and strike the inclined plane. It's certain at point A I projected at t equals 0. We have to get that range, time of flight, with what speed it will come and strike the inclined plane. All these quantities are to be determined. Take this one here. So this is let the angle of inclination be theta. How to get this? How to analyze this particular motion? So again, we have to apply the equations of motion along the incline, perpendicular to incline. So what do you mean by along the incline? So this direction, and another is perpendicular. So this I'll call as perpendicular. There's a unit vector I'm bringing, and this is called like a parallel. In the books, they have made this as x-axis, y-axis, because let's not disturb x, because we know x-axis is horizontal, y-axis is vertical. So I'll call parallel to incline, perpendicular to incline. Now, how G will act? So here also, again, the G will act vertically down. G will act vertically down. So we'll go for resolving this one. As we know, G is acting vertically down. This angle is theta. -90 minus theta. This should be theta. So this should be the G sine theta. And this one will be G cos theta. The G sine theta is along parallel. And G cos theta is along perpendicular. Everything, all the velocities, everything, all the things, will just analyze it parallel to incline, perpendicular. Similarly, the velocity vector also, we will resolve it. U parallel, U perpendicular. So what is that U parallel and U perpendicular? So what can be U parallel? U parallel, we can call it as U parallel as U cos theta. Here theta will come. U perpendicular will be U sin theta. G parallel, G sin theta, I resolved it. So now it will come and strike the B, and this is some perpendicular with respect to inclined plane. H perpendicular, we'll call this. After some time t, it will come and strike here. This is the time of flight. So first we'll calculate the time of flight. So what is the displacement perpendicular to incline? The ball will go like this. Again, will come and strike. So what is the displacement perpendicular to incline? Is 0. It will ascend when it moves from A to C. What is the height it will ascend? H perpendicular. When it moves from C to B, it will descend same H perpendicular. So what is the net displacement perpendicular to incline? Will be 0, no? So that is what I'm going to take help of it here. So let me analyze the motion first. The displacement perpendicular to incline. S perpendicular equal to U perpendicular T plus A perpendicular T square by 2. What is the net displacement perpendicular to incline? Must be 0. U perpendicular is how much? U sin theta. Time of flight, I don't know. Then A perpendicular. How is A perpendicular? That A perpendicular is what? G perpendicular, no? Here. I'll write G. This will be. So how it is directed? G perpendicular, opposite to U perpendicular. So therefore, this should be negative. So minus G cos theta T square by 2. Or the time of flight equal to 2U sin theta by G cos theta. This is the expression for time of flight. Displacement, net displacement from when it moves from A to B, what is the net displacement perpendicular to inclined? Should be 0, no? Yeah. Huh? Plus H minus H, plus H minus H, 2 minus 2, 0, non-zero. Should be 0, no? Make observations. Okay, this is a time of flight. So this quantity is called as time of flight. So I'll write reason, displacement, net displacement. Net displacement perpendicular to incline is 0. Plus H perpendicular minus H perpendicular will be 0. Okay, I got the time of flight. Keep in hand this, after this. Okay, after getting time of flight, I'm interested in knowing this speed. With what speed the ball will go again, will come and strike back the inclined plane. This has to be determined. So here, this velocity also will resolve it. It will become V parallel. This will be V perpendicular. Then let's again perpendicular to incline. Perpendicular to incline. V equal to U plus CT form. How V perpendicular? Opposite to U perpendicular. So minus V perpendicular equal to U perpendicular. Then how is G perpendicular? Opposite to U perpendicular. Minus G perpendicular into T. This is the thing which we are supposed to calculate. Let's go for it. What is time of flight should be equal to? From here, I'll write one more step here. I'm writing one more step so that it will be easy for you. later, U perpendicular, G perpendicular, substitute that, we'll get the answer. Okay, this one will be, this will be a better idea. We'll have like this. No, in place of T, what you can substitute here? In place of T, 2U perpendicular by G perpendicular. So minus V perpendicular, U perpendicular minus 2U perpendicular. So V perpendicular equal to U perpendicular. So finally, what do we get? With what speed it was projected normal to the incline. This was a per component of velocity perpendicular incline. With the same speed, it will strike normal to the incline here. Okay, I got one component. What about the other component parallel to incline? I'll apply again the equations of motion along the incline here. So the next part will be, I'll make it blockwise. Yeah. This is called as a parallel to incline or along the incline. Language, your language should be strong enough. Normal to incline, perpendicular to incline means this one. This direction is perpendicular to incline. This is called as along the incline or parallel to the incline. Got it? No, along the incline. V parallel, U parallel plus G parallel T. Sir, how come you are writing V equal to U plus CT formula? Final velocity V parallel, initial velocity U parallel. What about G parallel? How G parallel is along the incline? V equal to U plus AT formulas. Okay, no, after this, we will go for substituting all these quantities. U parallel is U cos theta. G parallel is G sin theta. 2U sin theta by G cos theta. So here U cos theta, GU cos square theta, 2GU sin square theta. Don't remember anything. I'm just deriving. You can directly take values. If you feel this line is like 30 degrees, project with some 15 meters per second, G is 10, solve it. I think in exams you may encounter numerical like this here. V perpendicular. I think one GU sin square theta, GU you can take outside. In that cos square theta, one sin square theta will get eliminated. So and the one G will get cancelled here. So this will become U 1 plus sin square theta by cos theta. This will be parallel component. Cos square theta plus sin square theta plus sin square theta. So this will be. Now what is the total speed? Total speed should be vector sum of these two. Then definitely it will strike certain angle. This angle we don't know. We'll call that as say some alpha. Angle of striking with respect to incline. Angle of striking with respect to incline. So it was projected at an angle theta with respect to incline here. So this angle should be theta. So theta and alpha, will it be same? I'm asking myself. Okay, what is tan alpha? From the data, tan alpha should be equal to V perpendicular by V parallel. V perpendicular is nothing but U perpendicular. This is equal to V parallel. V parallel is U. Let me substitute all. V perpendicular is U perpendicular. How much it is? U perpendicular is U sin theta. I'll substitute the values. 1 plus this will be sin square theta by cos theta. So this will become cos square theta. Will you agree that alpha should be equal to theta? Need not know. This alpha, you can also show it to be here. Am I right? So theta and alpha will not be equal. So many things what we have brought here. So afterwards, this is called like a range along the incline. Can we calculate this range? Almost everything. Okay, now we'll go for the next part, the range. Now where R is called as a range. Now what is R should be equal to? U parallel.
Sir, last one, have you got, sorry, cos square theta by 1 plus sin square theta?
It should be sin square theta by 1 plus.
Sin theta cos
Yes,
theta.
sin theta
Yes, sir,
cos
sin
theta by 1 plus.
Yes, yes.
1 plus
Yes.
sin square theta.
Okay.
Yes.
I am also human being. No, I should do mistakes. Huh? Okay, now fine. After this, we'll go for the range. S equal to ut plus half it square formula. Where along the incline. That's all. Along the incline, perpendicular to incline. Along the incline, perpendicular to incline. That's what incline projectile motion. So I'll be doing some 20-25 problems, but all those 20-25 problems will be just discussing only these things. Tomorrow interested, you can bunk my class because nothing new I'll be discussing. But every problem I'll be using this method only. You may find different problems, but all problems I feel like we're applying one same old concept. U parallel will simplify for U parallel. U parallel is U cos theta. This I think will end up with a very lengthy equation. I'll just leave it. It's a range, or we'll solve one, no problem. Time of flight 2u sine theta by g cos theta. Then G parallel is G sine theta t. This will be 2u sine theta G cos theta. It's not a trigonometry class. It's a physics class only. Okay, agreed. So this will be the range. Range along the incline. What is this R? Range measured along the incline. So we'll write it here. At what depth the projectile will go and strike the incline? Depth means somewhere here, no? This is called like a depth. So once you know range, we can calculate the depth. I think if you go down, we should call the depth, no? If you rise up, we'll call altitude or height. So at what depth it will strike means is asking this vertical distance. And once you know range, I think we can calculate that also. Okay, this distance is called as a depth. This vertical distance. Vertical separation between A and B is called as a depth. Almost everything we have just dumped here in one page. All different quantities is what we have determined. How to calculate that H perpendicular, displacement perpendicular to incline? The displacement perpendicular to incline should be calculated. Yes, for that also we can apply equations of motion here. Between from A to C, we'll apply it. Write it down. I'll scribble down. Sorry, I'll scroll down. Yeah.
It's perpendicular the maximum height, sir.
Perpendicular to incline.
Sir, is it the maximum height, sir?
Perpendicular to incline, maximum height, perpendicular to incline. Read the sentence. Huh?
Okay, sir.
Anything up the incline, positive. Anything measured down the incline, negative. Some minimum basics are missing, few of them. Please improve. Anything measured in this direction, positive. Opposite to that should be negative. No, that was the convention. Why we negative? Why this is negative means there's a convention. What happened all these days in equations of motion, studying and forgetting? Okay, let's calculate the H perpendicular. So H perpendicular means displacement per maximum height, or I'll not give any specific name, or the maximum displacement perpendicular to incline. Maximum height perpendicular to incline. That is called as H perpendicular. How to get that one? So I'll apply equations of motion from A to C. Yeah, from here to here. I need that U perpendicular. Yeah. At this point, how it will be? The total velocity here should be parallel to the incline. VH, you call it. And now it will be parallel to the incline. Then only perpendicular component, this U perpendicular will keep on decrease due to G perpendicular, and finally it will become 0. Then the total resultant velocity will be parallel to the incline. This will be parallel. You can give any some VHL, right? Velocity at highest point. What do you mean by highest point? Not with respect to ground. With respect to ground, this may not be highest point. It is somewhere here, no? So perpendicular to the inclined plane, this is the highest point. So we don't usually call by anything. No specific name for this. Just I'm giving some symbol VH. So what should be the U perpendicular here? Should become 0. The total velocity will be directed parallel to the incline. So let's apply equations of motion from A to C. This will be 0 square U perpendicular square to minus G.
So U perpendicular is 0 or V perpendicular?
What you are asking? Along this direction, you are applying equations of motion, then this component will become 0 here, no?
In the formula you substituted.
Correct, no? Final velocity is 0. Initial velocity U perpendicular.
Okay, sir.
Huh? So therefore, what is H perpendicular? It's equal to U perpendicular square by 2G. What is U perpendicular? And there's a G perpendicular, sorry. Yeah, now go for it. So we know all these values, substitute that, we'll get the maximum height perpendicular to incline, not with respect to ground. So these are all some quantities related to this one. So it's all about the resolving velocity along the incline, parallel to incline, resolving acceleration along the incline, parallel to incline, then applying equations of motion. And a rough idea must be there for us. How do the ball will move? If you don't know this, I think big headache, no? You can't just say that it'll go like this or it'll go like this. No, if you project it, it'll strike here. It will strike the lower steps.
Sir, minus U1 perpendicular square by 2G perpendicular, no, sir.
Sir, there you wrote.
Okay, that's one.
H, sir.
Yeah, fine.
Yes, sir.
Yeah, I made correction. No, this is just some, I'm making you to write equations of motion. That's all. So many symbols are there. We'll take some numerical value, will become very easy. Then and there, you're going to get answers and you're going to proceed all these things. We'll take the next, instead of just discussing theoretically, we'll have a numerical. So it'll be better.
Sir, one scroll up.
I have to scroll up.
Thank you, sir.
Okay, I'm going to throw a ball with a speed and this angle, let it be 30 degrees. Let's not write all that trigonometry to become trigonometry. Let's do physics problem. Okay, let the speed of projection given, let it be 8 meters per second. At t equals 0, at point A projected. How I'm projecting? I'm projecting it perpendicular to incline. Let's study what is the range, time of flight, all the other things. At t equals 0. At t equals 0, a ball is projected with a speed u at an angle with speed u from point A normal to incline. Normal to inclined plane. Find range. I'll write these things. Find the range, time of flight, and the speed with which again it will strike back the inclined plane. All things will find out. No. Okay, I do suggest you like don't derive, better directly, because you have to go for the numerical analysis. No? This one. So what is the method again here? What will be this? Like resolve along the incline, perpendicular to incline. Sir, I'll resolve along X, along Y. Okay, do it. You can do, no problem. Are you getting? No? You can do that problem. It's left to you. I feel very easy along the incline, perpendicular to incline. Sir, I'll resolve velocity along X, along Y. Okay, carry on. Nothing wrong in thinking very random. If you want, okay, first do with respect to this, then resolve velocities along the incline or along X, along Y, work out, you'll get same answer. Equations will be different, but you'll get same answer. First, what like how the ball will move. Okay, sir, ball will go straight, will not return back. No, not correct, no. So the ball is going to, because here the G will act down because of velocity and the G. So what do you expect? It should deviate from the velocity from here like this, or should go like this. Sir, what is there, sir? Ball will go like this and strike the ground. Okay, you do one thing, throw, go outside. I think every home will have some steps. From there you throw it. See how the ball, if it goes like this, not possible, no. So it.
Unte?
You know, we should like actually, to be frank, the total world is now run by ohms. You know, the home where you are staying, what happened, almost all. Past 1 year, I'm working from home. Almost all the companies, everything. The ohm has become now a base for the whole industry. So any disturbance, I think I should not scold anybody. You go outside, possible. A lot of disturbance, at least in home, they're making so much of like a conditions so that no disturbance should come to your room, everything. The entire past 1.5 years, the whole economy of the world is now is governed by the peaceful environment in the home. Getting this one. So let's not blame any person in our home where they're making noise, because that too, it's not 1 hour, half an hour, no, the whole day. The whole day they have to be quite calm. I think a lot of sacrifice is also there. Not only this, the whole economy of the world is run at home. The very home where no, nothing, no problem. It happens, no? Say some earlier, some intentionally, some people will do it. Nothing wrong. I will strike vertically. Somebody gave answers. Okay, good. Yeah, carry on. I'll draw the trajectory properly. should not strike. Yeah. We'll calculate all the things. The
Sir,
time
in question they did not give the angle of inclination, no, sir.
30 degree is what? Open eyes.
Diagram you showed. I got in question you did not.
Diagram is indicated. No, what is this? Almost 1 month over. Huh? 1 month got over. Shall I write one paragraph here, big paragraph? Okay, now let's resolve G. So here only let me resolve. So this will be much easier, no? This will be, I think everyone knows resolving of vector. This is G. This is G parallel, G perpendicular. That U is U perpendicular. What is U parallel? U parallel is 0. Because how it is projected? It is projected
Parallel to
normal to the incline. That's why U parallel is 0. Okay, let's first get the time of flight. Again, the same thing, perpendicular to incline. Perpendicular to incline. So this should be the net displacement perpendicular to incline should be 0. So therefore, this U perpendicular T minus G perpendicular T square by 2. 0, U perpendicular is U, I directly substitute value 8. G perpendicular should be how much? G cos 30. 5 root 3.
5, sir. 5 root 2.
No repeat again started. So this will be value 5. So G perpendicular will be, this is a G parallel. See, I'm wearing noise cancelling headphones, and some of you are those who are wearing headphones know if somebody speaks, lot of like a humming sound will come. That 2-3 students know. I think this is my 7th hour. So just what will happen to my eardrums? Just imagine. That's why I'm trying to. Usually, I'm a person who will not speak much and don't like to hear much. To be frank. I'll speak very less. Only when physics is there, I'll speak here. That too, I don't like to hear to anybody also. That one. So that my natural, you can say that one. So that's why maximum I'll try to avoid like anything from students. Only doubt is that okay, you can how you can help me where all needed or doubt you can clarify it. Okay, G perpendicular. So this will be 5 root 3 by 2. Okay, T square we don't know. Let it be as it is. So this will be 1 T will get cancelled out. So this will be 16 by 5 root 3. So G perpendicular, everyone hope G cos 30 degree, cos 30 root 3 by 2, 5 root 3 it will be. Yeah, this will be the time of flight. Then afterwards, we have to go for the range. We'll go for the range parallel to incline. Initial velocity U parallel. Let's write some equation A parallel or say G parallel T square by 2. U parallel is 0. G parallel is 5 by 2. This will be 16 by 5 root 3. Range is equal to 8 by root 3 meter. This distance will go in strike. So
T
yeah.
squares, no, sir.
Sir, T square, sir.
T square, I didn't.
128 by 15, sir.
128 by 15.
Yes, sir.
Let's leave it here. Okay, here also I think, agreed. Okay, these are the some values I got it, time, range. Okay, let's go for the calculation of speed. So it will have two components, one V parallel, other will be V perpendicular. V perpendicular is directly equal to U perpendicular. It's going to help you, or else you solve it. So this should be equal to 8 meters per second. V parallel will be U parallel plus G parallel T. U parallel is 0. G parallel is 5. Time of flight 16 by 5√3. This is the parallel component of velocity. The total speed just general, I think this V should be greater than U, no doubt. The V should be greater than U, and this angle is what we indicated. And that angle is what here will indicate alpha. So tan alpha. V perpendicular by V parallel. V perpendicular is 8. V parallel is 'So can you expect this alpha? Alpha is not nowhere equal to theta, no? You can see very much from the discussion. Okay, with this speed, it will come and strike the point B. So can we calculate the depth where it is striking? Depth means is asking this distance. I think we know the range. From that range, we can easily calculate this depth. I think quite easy, no? This one, it's all about equations of motion only. Now, few important things. I'm interested in this. Some important analysis here. After what time it will be here? At half of the time of flight. And we indicated this velocity VH. At t equals 0, it was projected. After some time, half of the time of flight, it will be here. Then at time, capital T time of flight, it's strike here. And then anything, can we say x1 and x2? I think this is something very important in drawing the trajectory. Anything, can we say x1 and x2? Which will be greater? The sum of x1 plus x2 is what range? We know it. I'm just general, I'm asking. So which will be greater, x1 or x2? I am expecting answer.
X2.
X2, sir.
X2 should be greater. No, the reason for that, in what is G parallel? Acceleration along the incline. In uniform accelerated motion. Sir, where is uniform acceleration, sir? Along the incline. Along the incline. There's uniform accelerated motion. Then distance covered in equal intervals of time should increase. In first half, it will cover x1. The next half, we should cover more with more distance, no? So x2 must be greater than x1. I think this data will help us to draw the trajectory. The data means, sir, only when you draw perpendicular, when you throw perpendicular, will it be like this? No, need not, even here also. So can we say anything about x1 and x2? This distance is x1, this is x2. Can we say anything about x2? X2 will be greater than x1. And what is it? This time of flight to reach here will be off of it. Very important. So many will help us to draw the trajectory here. So therefore, when you project a projectile down the incline, how the trajectory must be. Whatever design, you cannot draw your own designs. I mean to say, whatever designs you like, you should not draw it. So what you should do, you should follow certain rule. What that rule says, if there's an inclined plane, this cannot be the, don't draw like this. So the several cases are there, we'll analyze all. And this is one more basic information what we must know it. First time, okay, there's another thing I'm showing it. It'd be like this. The another one. The perpendicular one, I'll indicate at least with that it should flash for you. So when you throw an object like this, either way, you are throwing it normally or whatever be that. This is the angle of inclination theta. Then in all the cases, so this is equally you're telling x1 equal to x2, not possible. Should not happen here. X2 should be greater than here what you're showing. This is x2, this is x1. I think this is wrong. Because what is the time of flight here? T equal to 0. So what you are saying that one here. So this will be wrong, no? I'll say this is wrong. This is also a wrong. And here you are writing x1 equal to x2. Here you are showing clearly. And here you are showing that x2 less than x1. So this is wrong. This is wrong. This one only is correct. And the correct one I'll highlight. Got the idea, no? So this is the, I think, so many things which we have to be careful here. X2 greater than x1, sorry, yeah. Okay, that's what here. So if you want to calculate, now we have a numerical. You calculate, definitely x1 plus x2 will be r, and x will be greater than x1. Okay, I think we'll be in better position. So numerical also we can verify it. If you're interested, you can go for it. I think not that difficult, no? To some extent we can manage. It's not that something very, very difficult. Okay, first you scribble this. I'll scroll up also. First you finish off this.
Third, there is uniform accelerated motion parallel to incline.
Yes or no? I should ask this question.
Then, sir, which type of motion will be there perpendicular to incline?
G parallel, G sin theta, will it change?
No.
Then uniform accelerated motion along the incline. Then next, you were asking something perpendicular.
Sir, and in motion of perpendicular to incline, there also it will be uniform.
Uniform accelerated motion. Yeah, in fact, right. Good observation. Yeah. Perpendicular to incline and parallel to incline. What is the motion? Uniform accelerated motion, but perpendicular incline, what is like a first retardation, then acceleration. Along the incline, only acceleration. That's for the projectile down the incline. So what we are doing, there's a projectile down the incline. So there's a conclusion one has to make it. So projectile down the incline. So what do you mean by down the incline? You are throwing it so that the ball will go and strike somewhere lower place than the point of projection. This is the point of projection. No, this is the point of striking. Where the point of striking is below that, it's called a projectile down the incline. So projectile down the incline. What actually happens here? Uniform accelerated motion along the incline. Then uniform retardation, first uniform retardation, and then uniform acceleration. Perpendicular to incline. Okay, this one. Yeah. Okay, we'll go for projectile up the incline.
Sir, 1 minute. Sir.
Yeah, I'll wait. Still anybody not understanding? So you have steps, ramp in your home. Try once. All these, what all I gave diagrams also. Analyze it. Tomorrow class at least should be in a better position. You don't want to think, don't want to analyze, and don't want to analyze practically also. Then nobody can help you. You don't want to put effort. If when you don't put any effort, not possible. Knowledge will not come like that only. Knowledge will come by struggling, by putting effort. So it's a wrong concept. Some of you may feel very bad that you pray to God to give knowledge. You'll just say that, okay, instead of praying me, why don't you put effort and acquire it? There's a thing, no, it's still like I kept that knowledge in the nature. Make observation of nature, you get the knowledge. If you go to temple, mosque, church, you don't get this physics knowledge, scientific knowledge. I'm making things clear. Yes, God will help you to acquire knowledge, but God will not bless you with knowledge. There's a wrong perception. So I don't like you people going to temple for sake of this. As you pray to God to provide a favorable condition, but just don't pray that bless me with knowledge. I think God is more intelligent than me, no? Why you will bless simply? You should justify everyone, no? The person who has struggled, who is putting effort, who is doing analysis, who is throwing balls, standing on steps, I think God will bless him. Why will bless you? If you take coconut, banana, or if you go to the church, how come God will please you when we don't put effort? So put effort, you'll get knowledge. Don't put effort, nobody can help you. I'm very particular about putting effort. Sir, morning 4:30, I'll get up, I'll do puja. Okay, you'll become Vedic scholar. You will not become physics scholar. Have clarity with you. So morning, I'll get up, I'll do yoga. Then you'll become yoga teacher. You will not become engineer. Of course, no, sir, I'm just doing yoga to maintain my health. Good. But don't do yoga to gain physics knowledge. How it is possible? How yoga and physics are related? I don't know, some parent called, no, my son is, I'm making him to get up 4:30 morning so that he'll do yoga. Then he can improve his concentration. I think Newton Einstein did yoga. Nothing, no. Please do understand. So be in reality, it's a wrong perception that knowledge will come by some other means. No, knowledge will come by putting effort only. Just follow the Western science. See, you want to be engineer, follow the Western science. You want to become Vedic scholar, follow Indian philosophy. Two different things are there. They're totally different. Maybe at higher level they'll meet, but the level what we are, they are different. Okay, I'm making things clear. Don't mess up things here. Some students are inclined towards religion. Nothing wrong. Okay, religion will make you a good human being. That's all. Religion will help you out to distribute this knowledge. That's all. But religion may not help you to acquire this knowledge. This knowledge can be acquired by scientific method. Follow that scientific method. That's all. Very simple. I'm very particular about some of the things. I'll scroll down. Okay, note down x2 greater than x1 is what I wrote in the first diagram. So those who have missed it, enter it. Second diagram also, x2 must be greater than x1. I think I didn't indicate anywhere. Yeah. Yes. Let's go for projectile up the incline. Now we are going to throw a projectile. Up the incline we'll discuss here. Projectile up the incline. I'm going to throw a ball here. Let's take this point. Yeah. Now, say this is going to go like this and will strike. Sir, how do you can draw such diagrams? Okay, shall I draw like this then? Or shall I draw like this? First it'll go, then. Quite natural, no? Let me throw the ball. Let me stand at the lower steps. I'll throw the ball towards so that it should strike the upper step. The path will be parabolic. Sir, are you sure? Yes, from my side, I'm saying I'm very sure. Your side, you are not sure? Okay, go and verify it. These are things. So now G, we have to resolve G. So let me show that splitting up G here. So this will be the G sine theta or G parallel. G perpendicular. So what is G parallel? Should be resolving of vectors G sine theta. This will be G cos theta. Similarly, resolving the velocity component. I'm projecting this with an angle alpha. So the inclined plane, what is inclined plane? This is inclined plane. What we are doing is like, I'm projecting that. So, sir, can I project normal? As if you project it, say, I think some, once again, you must have certain things. If you project normal, how do it will move? The two trajectories is what I show it. Which one use? Shall we go for the one or two? Definitely two. Sir, how come? Here G will act here, no? Say whose help you have to take it? G. Because the velocity and acceleration should deviate away from velocity. Yeah, this is correct. No, here. How come it will go like this? Sir, what's wrong here? It will deviate here also. it should deviate the resultant velocity vector. The path should be between the velocity and the force it is acting. It should not be in this side. Not possible. It should be deviate in the resultant path. The resultant of these two will be somewhere here like this, no? So it is going to come here. Okay, fine. So it cannot be like this. This is not possible. So later on, I'll come to this one. So have a general idea. I'll keep it. Okay, we'll proceed now. So now U parallel, U perpendicular. So this will be U parallel. This is U perpendicular. So what type of motion? It'll describe I'm projecting from A. So it'll go and strike at point B. B perpendicular. Just some call came from college. I'm going to project it up the incline. Then V perpendicular, this will be a V parallel one. With respect to horizontal, you can define the alpha plus theta with respect to horizontal. You can do horizontal oblique projectile problem also. Let me do up the incline this one. Let's write all the things. I'm projecting up the incline. So first we have to calculate the time of flight. So it will take some time t to reach here. And time t by 2. Then let's go for the range. How do we can calculate the range? Okay, the range is equal to, first we'll calculate the time of flight. Displacement perpendicular to incline should be 0. So this should be equal to U perpendicular t minus G perpendicular t square by 2. U perpendicular is U sine alpha t, or will have some. So t is equal to 2U perpendicular by G perpendicular. I need a lot of space. Okay, finally, this should become equal to U perpendicular is U sine alpha. G perpendicular is G cos theta. Keep it in hand. Okay, let's calculate the range. Range along the incline. Range along incline. I think it's a very specific here, along incline. This how to find out this one. Range is equal to, this will be U parallel T minus G parallel. Sir, what is this? Why you are bringing negative sign? The G parallel is acting opposite to U parallel. Look at here, these two. G parallel is acting opposite to U parallel. So therefore negative. Why R is positive? You are measuring the range along the U parallel. So therefore this is positive. I think substituting all this, we'll get expression for the range. U parallel. Where is the U parallel? U cos alpha. G parallel will be G sine theta. 2u. Okay, this will become. No, we'll leave it, I think. Okay, this is a range like this we can find out. What about the velocities? Let's have that one. V perpendicular should be again equal to u perpendicular here. I'm writing directly. Here also the same thing. What about V parallel? U parallel minus G parallel T. So what do we expect the final speed? V parallel square, V perpendicular. Will it be less than u or greater than u? V will be less than u. Then we have something like x1 and x2. Anything about x1 and x2?
Sir, is
One is
x1
greater
greater
than
than x2?
One is
X1
greater than x2.
x1 must be greater than x2. Then it will come and strike at an angle. What can be this? Some angle phi, I'll write it. Phi and alpha, will it be equal? So some, okay, let's go for tan phi is equal to V perpendicular by V parallel. Definitely, they may not be. All this data is needed. So a student must have a basic general thing.
Sir, always V perpendicular will be equal to U perpendicular.
What do you mean by always, Ma? Why you are saying always? Why you want to say in inclined projectile only? The two point of projection and point of striking lie on same inclined plane. Okay.
Okay.
Sir, in the projectile down the incline, the first page, sir, that time, sir, can you scroll the page, sir, once I have a doubt? Sir, yes, sir, here, angle of inclination and the, angle of projection and angle of inclination are same, sir.
It happened, no. Like I don't know mathematics, you don't know maths, geometry. Huh?
Okay, sir.
This also I should tell.
No, sir. Because here it was not equal, sir. That's why. I got clarified, sir. Got
Okay.
clarified.
Yeah. Making observations, see, very essential. See, nothing, don't blame me because I'm assuming that you know all these things in high school geometry.
Sir, can you scroll down?
We are here, projectile up the incline. At what height it will strike the incline means he's asking this. Can we calculate this h? How to bring this h into picture? So here I'll give some separate diagram. This is A, B, this is H. So somebody will trouble you with these things also. This H is what I'm asking you now. Now we know this is R, so sine theta. So what is H equal to? R sine theta. We know range. At what height from the ground it will strike the inclined plane. So what is H? You can how to define H? The height at which the projectile projected up the incline will strike the inclined plane from measured from the ground. This H is measured from the ground. This is the ground, no? They may trouble you. Instead of asking range, they'll ask you H. So if you know range from there, we can bring the H here. Several things can be asked. So just be ready for all the possible things here. I'll remove this. It will become a little bit for you. Yeah. Okay, let's analyze. What is the condition for the projectile to strike normally the inclined plane? It can happen that it may strike normally. Sir, what do you mean by normally? V parallel may be 0. So there are three possibilities are there. V parallel, non-zero, or can be 0. And V parallel can be positive or negative. V parallel can be down the incline also. First, we'll make it where there's a V parallel non-zero is what you are seeing. So if it V parallel becomes 0 means how did it strike? It will strike normally. Then under what conditions the projectile will strike the inclined plane normally? I think this is what we have to study this one. Okay, now let me give the question. Derive a condition for which the projectile projected up an inclined plane strikes normally again the inclined plane. I'm just bringing that, I am asking that condition. So what do you mean by this? Okay, let's get the diagram. I'm projecting a body from here. It will describe a trajectory such a way that it will strike the inclined plane here normally. Able to see this? It is in fact perpendicular here, no? At t equals 0, I projected. So let this be alpha. How that angle alpha and theta are related is what? Or what are the conditions? We don't know anything. Okay, let's see what we'll get here. So at point B, it will strike normally. Now we'll resolve G also. This will be G cos theta, G sin theta, G cos theta. Resolve velocity also, U parallel, U perpendicular. Let's get into the calculation. It should strike normally there. That's what the condition is. So first we'll calculate as usual time of flight after some time t. And I think I'll add up this. Okay, that's one. Come related to diagram, we have made that sentence. Okay, now get into the thing. What is the displacement perpendicular to incline? Should be 0. This part will calculate here. There should be 0. U perpendicular will be U sin alpha t minus G cos theta by 2. Yeah. T equal to U sin alpha by cos theta. There's an expression for time of flight. Okay, let's, what should be the condition for V parallel? V parallel will become 0, no? At point B, how it will strike? It will strike normally. So here, yes, you just indicate at least Hope everyone is looking at that symbol. It's striking normally, no? So V parallel must be 0. And in fact, at B, the V is equal to V perpendicular. V parallel is 0. So therefore, along the incline, this is perpendicular to incline what we wrote. Parallel along the incline, or parallel to incline. V parallel equal to U parallel minus G parallel T. This should be 0. U parallel is U cos alpha. G parallel is G sin theta, time of flight, 2U sin alpha by G cos theta. Cot theta equal to 2 tan alpha. U parallel is U cos alpha, no? If it strikes normally, this component of velocity should be 0. If this strikes normally, then what is this component? Should be 0, no? Resolve the resolution of vectors. Two tan theta equal cot alpha. I'm getting different thing here. Oh, okay. This one, cot alpha, 2 tan theta. Yeah. With any speed, if the angle of projection, what is that alpha? Alpha is with respect to incline. Alpha is with respect to incline. Alpha, angle with which the ball is projected with respect to incline. And theta is angle of inclination. If this alpha and theta are related by this equation, it will strike normally. So for any speed, yes, definitely no, we got answer in that way only. Means, sir, what is all possibility here? So if you project a projectile up the incline, what are the possibilities? There are 3 possibilities are there. Altogether, there are 3 possibilities. If you project it, when you project it up the incline, the ball will go and strike like this. Or the ball, when you project it, it will strike normally also. There's the one thing. It may strike in this way also. Possible. It can happen. Getting the idea? It can happen like this. It may strike horizontal also. One more last, if you project it, it may strike the inclined plane such that the velocity will become horizontal to the ground. So there's a one more possibility. We will bring that here only. You are projecting it such a way that I'll make this inclination a little bit more. I'll project it so that it may look at now it is. It will strike horizontally also. So I think you must be ready for all these conditions. So projectile up the incline can strike normally, can strike horizontally not with respect to incline, with respect to ground. Here perpendicular with respect to incline. Or it may strike in this way also, where V parallel will be opposite. It all depends upon the U, alpha, theta, what we adjust.
Sir, what is difference between first and last?
It is having some component of velocity in this way. I will show it. There is a difference, no? How is velocity not horizontal?
Yes, sir.
These are the four situations are there. We must analyze all these things one by one. So the perpendicular one is what? I brought it. Everyone, so stand on the steps, inclined plane, you know to search the steps which are there, no, they are the inclined plane. Okay, you stand at the bottom, throw the ball so that will go and strike the upper steps. It will become projectile up the incline. Stand at the top of the steps, throw the ball in such a way that will go and strike the lower steps, then become projectile down the incline. So analyze all this. So tomorrow what happened, we'll focus more on the numericals. Write it down first, we'll end up the class. I'll end up the class. Okay, kids, like today we had a discussion about the theoretical proposal, or can say theoretical ideas on the projectile on an inclined plane. That one. So it is not something very big. The thing what we studied earlier, the motion in one dimension, that only we applied along the incline, perpendicular to incline. So do analyze, have some general idea on this so that numericals will become very easy for you. You have to put effort. There's no other way. So all the mathematics, everything, just do focus. Just put effort some. Just mere seeing, nothing will come. You have to put effort. Sir, what do you mean by effort here? Effort means I'm asking you to take a ball, stand on the steps, throw it, then make observation how it will move. That's what we are studying here. Nothing big. I promise you that in physics, except modern physics, what all we study, no, all they are very general, down to the earth. They are down to the earth, nothing big. Only thing, student has to come out of that phobia that they are tough. No, they're very general things. Many times you might have played, you didn't make observation. Now you make observation.